Hey, I'm Thomas and welcome to day 15 of 100 Days of Code in IoT Challenge. Today, we're going to have a refactoring session on the code of ESP-based temperature-controlled IoT relay device that I finished building yesterday. And yeah, the plan is to start with cleaning up, refactoring bits and pieces. And while doing it, I'm going to introduce the concept of ticker or timer that is required for refactoring the API gateway class, because at the moment we continuously make the request to get the desired temperature, but my plan is to modify it to be able to send this request, let's say every 15 minutes, so intervals, instead of continuously send the request. So that is one thing to do. And another thing to do, which is the ultimate goal, is to end up with the set of tools, set of classes for ESP8266 for IoT development that I can reuse in any of my future projects or devices. So yeah, let's see how it goes. And yeah, let's move to the code now. So here's the device's code. And I'm going to start from cleaning this up, because you've probably noticed that yesterday when I changed the code for the relay to be temperature controlled, I forgot about these bits on the buzzer and the waiting time for the relay as well. So these bits we don't need anymore, because I removed the buzzer of the board. Switch on and off the relay is fine, but without the relay time. And checking for the buzzer, if it's off, if it's on, not needed anymore. Same with button pressed and buzzer and relay time, not required. Okay, for the float, for the t variable, I think it doesn't have to be variable. That is more like a constant. So I'm gonna call it a temperature range, and I'm going to create define a constant for those. So define temp range, and that is 0.25, isn't it? Or is it 0.25? Yes. So that's 0.25. So t not required either. And I think now we left, oh yeah, of course, this is not required. And button and buzzer pin also not required. Okay, so now I think we left with the code almost. Okay, I think now, yeah. So now we left with only with the code for the temperature controlled relay, right? Temperature controlled relay, and let's do some refactoring. Let's do some refactoring here. Let's think about how this code could be cleaner, and also let's think about let's think about this bit, which is loading the temperature. Something that happens like continuously, one after another, right? So if I could make this working in a different way, like every 5 seconds, like I said at the beginning. What I could do here is to modify the load temperature to be callback based. So essentially to take a function here, and that function would somehow, it's just an example because that's probably going to be a little bit more complicated on load, that just, that is being called with the float argument, which is going to be the temperature, when everything completes. And by everything completes, I mean the Wi-Fi is connected, right? The time is synchronized. And and that's essentially it. Those two conditions are required. But in order to do it, I have to to make it more reliable also than it is right now, because at the moment we're waiting for the Wi-Fi connected event, which is triggered only when we have a transition from not connected to connected. So in order for low temperature to work correctly, we need to disconnect from Wi-Fi if it's already connected. Otherwise, if it's already connected, we're never gonna get a Wi-Fi connected event, right? And this is something I do. This is the part of the design to connect to Wi-Fi at the beginning, set the clock, and disconnect, right? So we can, for every loop iteration, when we load the temperature, what we do is we connect, we read the desired temperature, and we disconnect, right? So we have some implementation details that need to be done outside of the gateway temperature client, right? Because like literally what I would like to have is for the temperature client to be self-contained, right? If I load the temperature, I would like my response to be guaranteed, right? Regardless whether it's error or not, I would like to get this response anyway, right? And what I could do is to modify that approach back to not 100% back, because I'm still gonna use probably even the dispatcher here, but essentially back to the callback approach. Why the callback approach? So to explain that, I need to go to the WiFiManager, because at the moment the way the connect works is essentially utilizing the loop method that's being called continuously, and essentially if it tries to connect only if it's not already connected. So yeah, if it's connected, then it doesn't really care, and that is never going to be dispatched. So ideally, I'm gonna start from making WiFiManager callback based, more like callback based. So first of all, I would like to get rid of the loop method, but it's not that easy to do right now. Why I would like to get rid of it is because I think the responsibility for running that should be put on the connect method instead, right? So yeah, let me show you what I mean. So if I could make a connect callback based now, so I'm gonna do function, and that is gonna take void, and is going to return the WL status T, which is the default enum for the Wi-Fi statuses, for the Wi-Fi status types on ESP8266, and that would be the callback, so on connected, right, and some sort of timeout as well. So that would be for the guaranteed response, right? So what if it tries to connect and it takes so much time? We probably want to have some sort of timeout, after which it stops connecting and just return something, right? Call the callback essentially with the different status than the expected one. So I'm going to define unsigned long timeout millisecond, and I'm gonna set a default value for 5000, which is 5 seconds, right? So now when the connect is called, when that completes, when connection completes, the on connected is going to be called, unless it doesn't complete and the timeout is reached, and then we just return we just call the callback with the error or something like that, the timeout error or something like that. I'm not sure if for WL status there is such a thing. There is a connect failed, so I could do connect failed, for example, if we decide to do that. Or also I could introduce my own enum for that, but for now I'm not gonna do it. Let's stick to what we have on ESP already. Right. Okay. Yeah, but you know, this timeout, there's not a trivial way to do this unless I keep the loop method here and I make use of millis. So, you know, that would make this class containing another class variable like the timeout time or something like this, right? Timeout time, unsigned long timeout time. And that would be set here, right? That would be like timeout time equals millis plus timeout milliseconds, right? You could do something like that, and then in the loop, check for that, right? So have another if, and if that happens, we would need to have another flag. I mean, you know, we would need to have possibly another variable for unconnected callback as well, right? To put it on this class, and then in the loop method that would be called. But what if there is multiple places from where the connect method is called, right? So we would need to have some sort of container, and that only makes the whole class, the WiFiManager class, only more complex, which I would really like to avoid. And I can avoid that because I can move the whole responsibility of dealing with timeouts to the timer class. Timer class, there's also ticker class. So just give you a quick explanation on what is the difference. So ticker class is something that we can include from here and just use like ticker, and then that can work essentially in a way that you use the attach method, and attach method works like setInterval. So it runs the function that you pass there, the callback that you pass there in interval every n number of seconds. But that happens outside of the main thread as far as I know. I did some experiments with that ticker, and it didn't work for me with what we're doing here. I gave it a try. I can even show you if you are interested. Let me know in the comments. I can upload the video with the test for ticker. I'm pretty sure there is a use for that, especially when you want your code to be as minimal as possible. So you sacrifice verbosity, you sacrifice readability of the code in favor of, for example, performance, or you have a very small task to do, and then I see there could be a use of the ticker. Let me just quickly check something, because I mentioned the thread. There is only one thread on ESP8266. I don't think multi-threading is supported. I'm just gonna type attach and gonna click through, and you see this is what I mean, like callback recorded in a sys context. Oh, but there's another one, callback recorded at the following loop after ticker fire. So there is a way to run it on loop. There is a way to run it on yield as well, which is usually used for the Wi-Fi operations. On ESP8266 is Wi-Fi operations, like sending packets, I think. The yield is used for. So there are a couple options. Right, so that's cool. But yeah, still, because you know, of the readability, verbosity, and also me wanting to try to build something like that myself, I'm not gonna be using ticker today. Again, let me know in the comments. I can make a video just for the ticker. So I'll be just, you know, working with the ticker only on the video. Today, I'm going to build a class myself. I'm gonna call it timer, because the ticket is taken. And essentially what I would like to have there is the timeout itself, right? So setting a timeout, a callback that will be called after specified amount of time provided to the method. Interval, which is again a callback that runs every a number of seconds or milliseconds, and maybe some additional methods to handle cases like this one, for example, where let me show you, where we have some sort of a conditional statement that needs to run in the loop. So it would be nice if I could put this into some sort of uses some sort of method that would run until a boolean is until true is returned, for example, right? Okay, but yeah, let's focus on the timeout first, because that's what I would like to do for the timeout to happen in here, I think, right? This is where we want this to happen, actually. So, okay, so what I'm gonna do now is to create a new file. I'm gonna call it timer.hpp, and I'm gonna start implementation straight away. So there's gonna be class timer, and that class we want few methods. So one method would be setTimeout, that is going to be void, and that timeout is going to take function, just a simple callback, and then unsigned long timeout milliseconds, right? So that's what we want to get. SetInterval is going to be the next one, but for now we're gonna focus on setTimeout, and for tick, right? We need to tick, because otherwise there is no way to evaluate any of those callbacks like it was with the event dispatcher. But in the event dispatcher, the method that evaluates everything is dispatch. Here in the timer, it works differently than the event dispatcher. So we need to call this method continuously in the main.cpp in the loop function, right? Okay, another thing that is required is the container, right? We need a container for all of those callbacks. So the simplest container would be a vector again, std vector, and I'm going to think more like forward, because setting a timeout, that's nice, but we also need to have a way to cancel the timeout, right? What if, we set a timeout for, let's say 10 seconds, but before this 10 seconds elapses, before that, like after 5 seconds, we decide we don't want this to be called, right? And with this sort of implementation, there is no way to cancel it. So that would make another method before I declare the container, which would be clear timeout. Clear timeout, and clearing the timeout needs to operate on some sort of timeout ID, right? And that timeout ID ideally is going to be returned by setTimeout itself, right? So now, once we set a timeout, we return the ID of the timeout, and then we can use that ID to clear that timeout if we don't want this to happen, right? And that's why the vector is going to need a struct, because pair is not enough, right? Just with callback and timeout milliseconds, we could use pair, but because we also have ID, the pair is not really gonna work. So I'm going to add a timeout struct, and on the struct, what I need is ID. I need next call milliseconds, right? and I'm gonna need the std function, the actual callback. And then on vector, I'm just going to put this timeout, and I'm gonna call it timeouts, surprisingly. Okay, and now essentially what's gonna happen in the setTimeout method is to call to push back to the vector, right? And what I want to push back is the timeout with ID. Okay, so for ID, we're gonna need to have some sort of, an unsigned int, some integer, positive integer. From my practice, the best way is to just define this as some sort of an index that starts from 0. And then I'm just going to pass this index, and then after this, I'm going to what the next thing that is needed is essentially the timeout plus the milliseconds, because that's gonna be like at the beginning, like we've done at the beginning, right? You probably remember the usage of millis, right? Plus timeout ms. So the usage of millis to set the time like in the future, right? The first one, the third one is callback, right? But for the millis, I'm going to define a private method that I'm going to call now. The reason is we don't want to, we want this class to be testable, right? So we cannot really rely on anything outside. Anything outside needs to be passed. So for now, I'm just gonna do that, but ultimately this is gonna be required in the constructor, and the middle is gonna be the default one. So that's gonna make it better. Okay, so you got this. Let me see if I can compile. I probably cannot compile because without compiling, I don't really have any way to, my hinting in my IDE is for some reason not working when I don't compile. So I'm gonna compile. Let's see if it compiles. It doesn't. Well, there's something missing, which is, what is this? The low temperature. So I'm gonna comment this out. I need to compile. That should compile now. Yeah, and let me just restart. Let me just restart. Reload window. Yeah. So now the timer should everything should be picked up. Oh yeah, it's not picked up. Let me just fix that. I think what I have to do is to include this, compile again. Okay, yeah, anyway, let me continue. So this one obviously needs to return an index plus because we need to increase the index after that. Then for clearing the timeout, what we want to do is to iterate. We want to iterate over timeouts. So that's gonna be begin, then IT is different than timeouts, and plus IT, and if IT ID equals timeout ID, that is the moment where I want to listen. That's not listeners, that's timeouts. Timeouts erase this timeouts begin plus sorry, that's not like that. Let's just erase IT. And this is important, we need to break after that. So there is no next iteration, otherwise that's gonna break. Okay, so that clears the timeout, that sets the timeout, and tick essentially is gonna go, that is gonna go through all of those timeouts and check for those that are ready to be called. And I'm just thinking what would be nice to do. I'm not sure on the complexity what is better. Okay, there are two ways. So one way would be to keep the timeouts as they are and just, go through them every time in the for loop in the tick. That would be on. And other way would be to sort them here when you set the timeout. So that is and that is O n log n, right? That is O n log n. So it's less efficient, but if we do that, then this is going to be much easier. Probably there's gonna be less iterations because of that, because when we have the data sorted, we can design the loop in a way that it only evaluates the callbacks that are supposed to be called and just breaks the loop right after that. If it sees the first element with the next call milliseconds higher than the millis, then that could exit the loop straight away. So yeah, let me know in the comments. I will do the sort way. So I'm going to sort it here. And for that, I'm gonna need to include algorithm and define the sort. So that is sort this timeouts begin, then this timeouts end, and the comparator function, which is going to be timeout t1, timeout t2, and essentially t1 dot next call ms is less than t2 next call ms, right? And semicolon here at the end. So that's gonna sort it. So now in the tick, what I can do is to make the for statement, this is less than timeouts dot size and I++. And what I could do is to check if this now is less than, so now we have a guarantee they are sorted, right? So this next call milliseconds, if it's bigger than now, there is no way that the next one is not going to be, right? If it's greater than now. So what I essentially can do is to exit the for loop. And here, otherwise, if that is not the case, what I'm just gonna do is to simply call the callback and then just erase it. So, erasing it is going to be timeouts dot erase, and this timeouts begin plus I, right? Because timeout happens just once. After that, we want this to be erased. Okay, so that is for timeouts. Let me just quickly compile the code. See if I didn't do any mistakes, which I have done. And this is weird. Let me check what is wrong. There is something wrong in here. Oh yeah, which is, I forgot about the return statement. So that's it. Yeah. Okay. Here, this is C++, right? Just a return statement missed. Okay. Cool. So this is timeouts. For the intervals, this is going to be quite similar, but for intervals, I'm gonna need another structure because intervals are gonna be a bit different. Before I move to intervals, let's consider the case with a different container, right? I just picked up vector without thinking. The reason I picked up the vector is because in terms of memory, it takes the least amount of size on the memory, right? It is like regarding so if you look at the cyclomatic complexity, this is less efficient program if we use vector, right? Especially with the sorting here that we need to do, which is less efficient than doing it with the map, right? I could just use map or rather a multi-map because map itself wouldn't work if we had two timeouts with exactly the same timeouts, this one, right? The sum of now plus timeout milliseconds, which I call next call ms, right? I'm obviously thinking about the map of unsigned long, which is gonna be the next call milliseconds, and then as a key, right? And as a value, we would have a callback and ID, right? This kind of map I'm thinking about. Because you cannot really sort them by ID because you cannot really tell if they are in order in terms of when they will be called. Okay, so yeah, so this is for the timeout. Before I move to interval, I can quickly test it. Yeah, I can essentially quickly test it. So we have code commented out right now. I maybe even comment this out as well, and this. So we have this in sort of isolation, and then I have to declare, I'm just gonna have to include this timer. And let me show you, timer. And now simply we want to do timer, set timeout, and the simplest idea would be to do with the serial monitor, and obviously printing out the millis so we can compare that. And we want to set it for, let's say it's 5 seconds, right? So for 5 seconds, after 5 seconds, we want to see time is, and we see what the millis amount is going to be. What is important is to run the tick method here. Okay, I'm gonna compile and let's see if it works. It is not, because I've made a mistake, which is redundant. Yeah, that's how it should be done. Okay. Great. So yeah, the timeout is the first one that we need. In the meantime, let's quickly have a look at the APIGatewayTemperatureClient. At the WiFiManager, because I was thinking it would be nice to have a timeout, but interval is another one that we need. The reason simply is that that will be APIGatewayTemperatureClient. So the reason is simply the load temperature. That's something we would like to happen every 5 seconds. And then for the WiFiManager itself, it would be nice to be able to set some sort of interval that runs on every single loop iteration until we return true. Or it could be false, but I was thinking true. So yeah, I'm gonna show you in a second, but let's test the timer now. So I'm gonna connect to the serial monitor and restart. So we restarted this, and we should see more or less after 5 seconds, which is, yeah, time is 6,000, right? So there is 6 seconds, and I can simply explain why 6,000, not 5,000 on millis. The reason is this delay here, which is 1,000, isn't it? If I remove that, surely I'm gonna get 5,078 is probably the time that elapsed from before this code has been executed. Anyway, let's do interval now. So for interval, I'm gonna also return unsigned int, so we can cancel interval. Canceling intervals is even more important than timeouts, and that's gonna take a function void, and that's gonna be our callback, and then we have unsigned long interval ms, right? And for that we need another container, because now we need a little bit more properties, a little bit more members of that struct. So this interval, apart from the standard unsigned int id and unsigned long next call ms, which is still required, we need unsigned long for the interval milliseconds. Gonna explain in a second why this is required. Not only those 3 like we have in the timeout, and then vector interval intervals, right? Good. And setting the interval, this is gonna be just intervals pushback, and we want to push back the interval, which is again this index. I could have another separate index for intervals, but you know, I would like to avoid a confusion if someone tries to use the index, the ID of interval for the timeout. I mean, that still can end up with the undefined behavior, but it's a little safety measure, and also saving the memory, right? We will have just 1 index instead of 2. So interval, we need the next call, and next call, again, this is gonna be this now. So the millis plus interval ms, because the first call of this is going to be after the specified time in the interval milliseconds, and the callback is the last one, right? The interval milliseconds is essentially required for the tick method to be able to sort of schedule the next interval, right? And I'm gonna show you how this is gonna be done. So yeah, intervals, and that's gonna be very similar for the tick, but it needs a separate loop. Again, this is essentially intervals size and I++, but inside we're going to have if this now, that stays as it is, but essentially what we would like to do is the other way around. So if now is greater or equal, then interval I next call ms. If that happens, that is the moment we would like to call the interval and probably schedule the next one. Schedule the next one. So we want to do interval.i.nextCall ms, and now this is the moment where we need the interval milliseconds, because what I'm gonna do is to retrieve now and add that value so we can schedule the next call, right? We can schedule the next call, yeah, and this is it for calling the intervals. As you can see, the difference is we don't really sort. We don't sort anything here. I could sort it, but because intervals, they usually, just continue running, right? There is not really any point in doing that, I think, unless, if you think it's better to sort them, and you can explain in the comments, let me know. For now, I'm not really gonna sort them. I'm just gonna iterate over all of them. So that's what we've got for interval. Let's see if I can compile it. No, I cannot compile it. This is because everywhere I called it interval. And there is something wrong here, which is what? Class timer has no member named intervals. Yeah, this is intervals, not. Yeah, that's my problem with the code hinting, but it's my fault because I forgot about the dumb semicolon. Yeah, that was the right warning. The index ++ needs to be returned as well. And probably you also realized I need clear interval method as well. So that is required here, clear interval. And that would be interval ID. Just this one and this one, right? Yeah. So that is interval ID, and that essentially runs on intervals. Intervals, okay. So now we have clear timeout, clear interval, and yeah, all of those containers required for them. Let's do a quick test. So going here, and I'm going to change this to setInterval, and that is going to run every second this time. So every second, just setInterval. Let's deploy and see how it works. Okay, so we got serial monitor. Let me restart it so we see from the very beginning. Okay, it starts from the second 2, right? Because of the delay here. And now it runs every second, right? It's very consistent. Okay, works really well. You can see how useful is this class, right? It is super useful, especially for dealing with asynchronous stuff. And what we could do with this is to add some additional utility methods like setImmediate. That would take just std function void and callback. And setImmediate is essentially just setting a timeout with the same callback, but it's just, it just runs immediately, right? So that would be setImmediate. Obviously, I need to return it, right? And for the setInterval, I can have a method called setOnLoop. Callback and there is no interval essentially, and that just runs setInterval with the callback and also 0, right? Very useful function here, right? So I can set something on loop and that continues indefinitely. Just runs on every single iteration of the loop. Okay, cool. Right. Yeah, so let's just move to the WiFiManager and let's see what we can do with the new timer, class. So let's define timer here. Let's take it in the constructor and let's assign this pointer timer, right? Okay, so now with the timer, I could have some sort of timeout in here. So there will be timer set, I think this is how it works, set timeout. And that timeout essentially would run after timeout milliseconds. And that would just call onConnected. We can actually call onConnected with connect failed. That's what we could do, right? The problem here is, though, that makes it incomplete, is that we need to have a way to cancel this timeout if this actually happens correctly, right? So if the Wi-Fi connected event is dispatched, for example, that's something I could do. Something like that, auto timeout ID, and then I could have something like this, dispatcher on Wi-Fi connected event. Sorry, that is not how this is done. This is how it's done. So once Wi-Fi connected event, and then we pass the timeout ID to the Lambda function, and then inside, when this happens, I could do this is also required, essentially this. So that'll be this timer, clear timeout, and timeout ID. That's something I could do, right? And for me, this is cool enough, right, for this to work, right? Because we cancel the timeout if we connect with the usage of event dispatcher. But that still leaves us with the loop method. And think about another case. Set clock. I would like to make it non-blocking. But because of this while method, I would need to go for the strategy of having a loop method, right? Do I need a loop method? No, I don't need a loop method. I don't need the loop method because I have interval now, or set on loop. The only problem is I don't have the way to stop it easily. I mean, I guess, yeah, what I could do, let me think about it. What I could do, if I wanted to move this entirely to connect, what we could do here, yeah, this is fine with the timeout and everything. And then I could say this timer, set interval, and set that interval for that bit. So completely getting rid of the loop method, right? Or even better, actually, set on loop, right? So I don't need to provide the value for the interval milliseconds. Should connect, not required anymore. Is connected, that is even better because that is not required either. What I could do is to make this check here. Like if it's connected, yeah, nice. It is connected. Then we just gonna call the callback that, you know, just stating that we are really connected. I mean, it would be nice to make sure that is the internal method for for ESP8266 to check the status for Wi-Fi, right? So we want to make sure it's not just this one, because if it's not, we're not connected. It would be nice to actually set it to false, just in case if that is actually not aligned with this one. There's other strategy, other way to do that, like constantly checking for the status, but that's later. So yeah, timeout ID and set on loop. We could set this on loop and get the interval ID here, right? The only problem is it really, actually that would be possible. Because we dispatch connected event, I can do again something like this. And you know, I'm not really gonna do it, sorry. Because for me that's still overcomplicated. Because yeah, and then I could just, you know, pass the interval ID here, and when this is connected, I could cancel this interval ID, right? I could do that. All of that is nice, but I think this is the code for this is not as clear as I would like it to be. And consider the case. Consider the case where I have something like that. Set on loop until, right? Set on loop until, and we have this being run on the loop function as long as we are connected. And when we are connected, then it doesn't run anymore. But we need to tell the timer. We need to tell the timer somehow. What I could do is to return true. Right, so set on loop until true, right? Set on until true. Obviously, I'm gonna have to return false otherwise, if it's not connected. And I can even add an extra functionality to it. I could specify another callback that would be run when the timeout happens, and then specify the timeout in milliseconds, right? So from the consumer perspective of the timer class, look at this case. So we set a callback that is being run continuously on the loop function, right? So really, really often, and then if it happens to return true, we stop running it. That was success. That's it. But if it doesn't return true after the timeout, time in milliseconds, so in this case that would be 10 seconds, we call this callback, which is a timeout callback, right? So that is going to be something to notify, hey, that didn't work. That's something I mentioned, I think, a few times already, about getting the result regardless of what happened, whether there was an error or not, right? For the APIGatewayTemperatureClient. So like with the load temperature, I would like to get the result eventually, right? With the timeout. So let's say 5 seconds. If after 5 seconds we don't get, you know, let's say time synchronized, like Wi-Fi connected, time synchronized, and the request made, that means it failed. Right, I just want to get an error and try again. So that's my goal here, right? Let me implement this on the timer. So for this to happen, to work, what I need to do is to modify the contract, the type of the function on the interval, to return boolean. For the intervals, I'm gonna have to modify this callback to simply be run here, but return false, right? If it returns false, it's gonna try again, it's gonna try again. It's always gonna return false, unless this is just completely cleared, right? Using the clear interval. Then, so that will be for setting interval. So set on loop is covered. Yeah, that is all covered. However, here, there is a slight modification that needs to happen. So I'm gonna go back to this approach where the now is less, but I'm going to do a continue then. Continue. So go to the next iteration, and only if it's the other way around, then we want to call it, but we want to check the result of the call. And if the result of the call is true, if it's true, then we want to erase it. Otherwise, we just want to schedule the next call. So this is gonna be where I erase it. So this intervals erase, and I would like to erase this intervals begin plus I. Right, so that's the moment we erase. Otherwise, we schedule the next one, right? So true means, yeah, I'm finished. And with this design, I can introduce the until method, right? So that would be something like set on loop until, but I would like to be, I would like to be more generic with that and give more functionality, and then like with set on loop, build another method. So this is gonna be more like not set on loop, but set interval until, maybe, yeah, assigned int set interval until, and that is going to take, it's like I did with set interval, did I? Yeah, that is going to take this, but the function is going to straight away accept a lambda that returns boolean instead. So that's gonna be our callback, and we allow for the unsigned long interval milliseconds, right? So that is going to run. For the interval amount of milliseconds, so like, you know, every second, until, and that's the moment where I want to return just a callback, until the true is returned, right? So if the true is returned, set interval until works, right? Oh, and the timeout functionality as well. So I think this is gonna be the base method. The base method is gonna be with the timeout functionality, and this one is just gonna call it. So we have interval milliseconds, then we will have function that returns void and takes void, and that's gonna be on timeout. And then we're going to have unsigned long timeout milliseconds. Timeout milliseconds, and this is going to push back everything, but with the modification now. and that modification will be on the callback itself. So what that callback needs? That callback needs, you know what? Actually, I think setInterval until is gonna be the base method, and this one is gonna use the setInterval until, because what I could do, what I could do is play around a little bit with the callback itself. So if I do something like this, so let me just return this setInterval until, that takes very specific callback. And interval ms is exactly the same. It's just the callback, and that callback, first of all, we would have the timeout calculated. So let's call it timeout call ms is gonna be this now plus timeout milliseconds, and that's gonna be copied over to the callback itself. And then inside the callback, we also need the actual callback to be copied there, and we're gonna need this. This is also required. Okay, and what I'm gonna do inside is to simply run the callback itself. So I'm gonna define a variable, let's call it should stop, and that's gonna run the callback. And then we're going to have an if statement inside, and that is going to check if the should stop is still false, right? So if it's still false and the timeout call milliseconds is now greater or equal to this now, oh, hang on, that would be other way around. Yeah, so the now is greater or equal. It's greater or equal to timeout call milliseconds, something in the future, right? This is the moment where we don't really want to return false. This is the moment we want to return true, because this is invalidated now. It's not valid anymore, right? So, you know, if after all that time, which is the timeout, we're still getting false, that means that's over. We need to remove that anyway. So I'm going to return true, and that true is going to get removed here, right? And otherwise, I'm going to return should stop, which is just the original value. So if this is not the case, we're just gonna return the original value, regardless of what it was. What additional thing I've just realized is the on timeout callback. So on timeout is something that we want to call when the actual timeout happens. And this is the moment when the timeout happens, right? So one on timeout is gonna be run here. Okay, that's a bit clever. I wonder if this is gonna work, or I get some C++ exception that I won't understand. Cool, so that is for set interval until, and set interval until this one, yeah, that just utilizes this one again, right? And for the setting the interval, to be honest, what I could do is to have maybe a common logic for the index plus plus. Okay, that's fine. It's not that important. Yeah, we don't worry that much. Cool. Okay. Let's give it a test, because I'm not sure if this is the right approach. Hang on. There is gonna be some issues now. So in main.cpp, there is some issues with, what is the issue with? Okay, so now we take timer here. So that needs to be created here above all of those. And this one is something that it doesn't really like, but I think that is going to solve the issue. So now we can sort of, there is set on loop until, something I missed, did I? So we have setInterval until and setInterval until this one. That will be the place where I have very similar one, set on loop until. That's gonna take exactly the same number of arguments. So we need both essentially, which is really gonna be, we don't need interval milliseconds. So just on timeout and timeout milliseconds, and that's just gonna return this setInterval until, and that takes callback 0 for the interval value on timeout and timeout millisecond, right? And another one is just going to take the callback. So the one with the callback is essentially running setInterval until callback and 0. That's it. Okay, so this is where you want to handle everything yourself without the timeout. Okay, so yeah, let's see if I can do it now. Still something missing, and this time what is missing? So dispatcher wants. Okay, yes, something I don't really need anymore. I don't really need that anymore. And I don't need that anymore either. This is gonna be where the onConnect failed is called. So here, right, onConnect failed. Obviously I need onConnected here, and I also need onConnected here, so I can run onConnected with WL connected. Okay, so I've got WL connected here, blah blah blah. Nice. Okay, I'm gonna test it in a second, but let's do some tests with the timer itself. I have some code prepared to test it in the main.cpp, because all the rest of stuff for now I have commented out, because I would like to check if the timer only works as it's supposed. So I've got some code prepared. Let me show you. That is for clearing the timeouts and intervals. So that's the first thing I'm going to test. Okay. And then we do the interval until. Okay, let me explain it. Quickly go through it. So yeah, maybe additional. Yeah, that should start from this one. I'm not sure why we didn't get it. Set interval time is, there's the old interval. Okay, I'm going to remove this one. Okay, so we start scheduling and we show the millis. Then I have two timeouts, different order, but this one should run first. This is one after 1 second, this is after 2 seconds. Then another timeout, 5 seconds, and after this 5 seconds, we set the interval that happens every 1 second, and we set another timeout that clears this every second interval after 8 seconds. So in total 13 seconds, right? Because this one is scheduled after 5 seconds. Okay, and here I have just a simple timeout, 10 seconds, but it's cleared. So it should never happen. Okay, so that's for the flow of code in this bunch of tests, like calls of the set timeout and set interval methods to test the functionality. I'm going to deploy now, and let's see if it works. So what you should see first is the 1000 milliseconds, then 2000 milliseconds, then 5000 milliseconds, and then for 8 seconds there's gonna be 1 second. After that 8 seconds, and that should never happen. Okay, so I'm just going to connect to the serial monitor and restart. Okay, so that worked. Bear in mind there is a timeout 1 second at the beginning. So there's always going to be 1 second more than should be okay. And yeah, essentially that works. Isn't it? Yeah, that works because this one didn't happen. Then let's start from the beginning. So we had this delay 1 second, which is this one, right? Then we see started scheduling 1 second, right? 1000 milliseconds. And then after 1 second, we have this one. Then this one after 2 seconds. This one after 5 seconds. And then every second, we get the interval until it gets to 14 seconds minus 1, which is 13 seconds. And that is correct because that's 8,000 plus 5,000, 13, right? And minus 1 for the delay. And then 8,000 seconds clear interval. So that didn't happen again, right? And this one essentially was cleared. So yeah, so that works. Let's test the until methods now. So I'm gonna keep this the first line, but this I'm going to remove. And let me just quickly paste the code that I prepared for this one. Okay, so here we have the simple I variable. It's just gonna increment. It's just gonna be incremented. I'm just keeping it here as a shared pointer, so I don't need to declare it globally. So just me also playing around with the smart pointers. But yeah, essentially what happens here, because that gets passed to the setInterval until callback, right? That just increments it, and that also increments it, right? So, however, as you can see, for the setInterval until, we should get 5,000 milliseconds, or maybe, just to make sure they're not really gonna. Oh, actually, they shouldn't. They shouldn't be. There shouldn't be any clash on the I value, because this one is set on loop. So that's going to run right after the program starts. It's just 50 iterations. And this one is, this one's probably not really gonna happen for long. So what I could do is to run additional, like do more than 60, right? Because this one's gonna run fast. That goes on the loop. So that runs fast, iterates up to 50. Then when it's over 50, it is going to stop. We should not see any timeout message, because that's going to be successful. And then for this one, essentially that's going to run as the next one, because there is a delay, which is half second. And we should see, I think we should see 10 iterations. We should see how it starts from 50, that should start from 51 and end on 61. Something like that. Yes, yeah, something like that. Yeah, let me just run this and we see how it works. And after that, I try to hang on, something wrong. Yeah, I think I just need to, yeah, that was just incorrect. Okay, connecting to serial monitor, and right away I'm going to restart. So we should see the loops, and then this starts and it stops. It does stop, right? It started on 15, and then every 500 milliseconds, 1500, right? And every 500 milliseconds. So we have like 2, 4, 6, 8, 10, which is correct, right? And yeah, you see that's how it started. So it started running the loop. That loop is run for 50 times, and then that was run. So that works, right? That works. Okay, let me check if it's possible to do. So if I just ignore that and I will say it's false, it's always false, we should see the timeout now. So let me run this again. 7 seconds timeout. So we should see after 7 seconds we should do the timeout message instead. Okay, we keep getting the loop. Timeout is 8,000, right? So you always need to subtract the 1 second delay. That is correct. We don't see any loop prints anymore. And now this is probably gonna run until I is more than 60. So that's gonna take a while. But anyway, I'm simply assuming that this is working. Obviously, that's not a perfect situation. Normally, if it was in a video, I would start from writing the tests, and I would probably do test-driven development with stuff like timer. But I haven't figured it out yet for C++ and for this embedded environment. I mean, this particular one doesn't really have anything to do with the embedded environment. I think that can be tested in isolation, but there's gonna be a special episode about testing, because yeah, that's also something for me to figure out. Cool. Okay, so timer is working, and since this is working, we can now make use of it. So essentially my plan is to think about the design of this program now and the way I would like this to run. Right, so for the WiFiManager, WiFiManager loop is not gonna be used. For the temperature client load temperature, as I said, again, repeated a couple times, I would like to run every X number of seconds and with the timeout. So, before this X number of seconds, there is a timeout. And basically, if by that time the Wi-Fi is not connected, or the timer is not synchronized, or the request has not finished, that is going to mean a timeout for me, and I'm going to return the message, right? Just print out the message that there was a timeout, and then after few seconds, it's going to try again. Okay, so that's how I see it. It is going to be a little bit different than normal interval, because essentially what I would like to achieve is to have something sort of running in a loop. So maybe a bit like a recursive list. It's gonna call itself. Imagine like having a function load temperature, and that basically set immediate callback to be called right away, and that callback essentially does some operations, right? Async operations with callbacks. Okay, and timeout as well, and timeout. Okay, so probably there's gonna be some callbacks passing inside those other functions or methods used in here. And only when it completes, so the deepest callback, the one that is going to run at the end, it is going to just call load temperature again. Okay, regardless whether it was success or not, it just runs the load temperature again, right? So sort of recursively. Obviously, that would start in the setup function over there. So that is my goal, to have this load temperature being run continuously with the timeout. Obviously, another thing that I could do if I want to have a time gap between those calls, right? Even if there is a timeout, because if there is no timeout, that should run quickly, right? Let's say timeout is 10 seconds, but usually the Wi-Fi connects and time synchronizes and everything is done in 2 seconds, let's say, right? But I would like still to have a gap between this call, this set of operations that happen to retrieve the temperature, and the next set of operations that are being done to retrieve the temperature. That's easy. That's essentially easy. I can just use setTimeout here. So if I do setTimeout and say like 3 seconds, right? So what's going to happen? This is gonna run, don't know how long, right? As long as the timeout is set for, if the operation fails, or way quicker, or just right before the timeout, right? That's the worst case scenario, is like 1 millisecond before the timeout, and then it schedules it again, right? Because it calls low temperature, and that low temperature is going to set the new timeout for this to run in the next 3 seconds, right? Okay, but in order for this to work like that, I have to go back to APIGatewayTemperatureClient. Let me look at this one first. So we got onload. Okay, quick look at WiFiManager as well. Because essentially WiFiManager is finished, isn't it? So we have connect method with the callback onConnected and with the timeout. That is default 5 seconds. We can stay with 5 seconds. And probably the first synchronization is going to fail unless this synchronization is done outside of WiFiManager, which is actually going to be. So yeah, just for Wi-Fi connection, we have 5 seconds timeout. And what happens here essentially is, it checks if it's already connected. Because if it's already connected, we just resolve this callback. If it's not connected to false, and we make use of the set on loop until, right? So what I've just tested. Right, and here, if we have success, this happens. If we have failure, this happens. One thing is that this is a timeout that we want it to be a timeout milliseconds, not 10 seconds, right? Okay, so now we have the 5 seconds here. For this one, I'm just going to keep as it is, but should connect is something that we don't need anymore, and I'm just going to get rid of it. Great. So set connect, essentially WiFiManager for now, it is done. And now APIGatewayTemperatureClient. So this one, it doesn't need to run it doesn't need to set the listener once, which there is no guarantee this happens. What I'm going to do, also request in progress is not needed anymore. We don't need to make this in a way that it knows about the implementation detail, which is the loop function that runs continuously, right? That should be completely independent from that. So WiFiManager connect is what we're gonna do now. And inside this connect, all of the inside of the Wi-Fi connected event listener is going to happen. So everything up to there is now going to be moved to this listener, essentially. So now we have WiFiManager connect. We can live with the 5 seconds timeout. That is fine. The only thing here is that we want this, probably. Do we want this? Yes, we want this because dispatcher is used. Even dispatcher is still useful because of all of the Is it really? In this one is not really useful anymore. Yeah, in this one is not useful. It is useful here. It is useful here still because, as I said in the previous episodes, the dispatch Wi-Fi connected is a transition from not connected to connected. So there might be some cases we would still like to have a listeners on that particular event because, you know, it cares about transition. Good example is the diode, the LED diode on the ESP, the blue one, right? So we have, I'm going to keep this, right? The built-in one. Set clock is gonna disappear from here because it's probably different case. But yeah, let's continue. So this is required. This is not really required then, because I'm going to get rid of the dependency on the dispatcher here, right? The flow temperature is going to stay in some way. For now, let's just keep it like that. I'm gonna change that in a second. But we need on load. We need on load, and that on load is incorrect. Has incorrect type because the way I see that is that it's not the way I see that. The way it works is essentially we can either get a success, which is the flow temperature, or an error, right? Or an error. So what I could do is to just, you know, call the unload here with the temperature, but in case of error, that would be something else. That would be something else, like, you know, reading this string. So maybe, you know, as a quick step, I could add a float. Maybe before float, I'm going to specify a const char. Maybe const char is not the best one, because we would really like to return something that is not going to go. It's not really gonna go out of scope. No, it's not really gonna go out of scope. Okay, so we can go with const char and float, right? So the const char will be the error, and it will be null pointer essentially if there is no error, and float is going to be the temperature. So here I could just run unload here, right? Just gonna run it here with casting to the float, and the error itself is going to be null pointer in this case. So that's null pointer. In this case, though, we're going to do unload, and the error is going to be this one. That is gonna be error, and the temperature is just gonna be 0. And we do HTTP end. This one essentially I'm just gonna run unload with some other error, which is gonna be just, you know, let me just write unable to connect, I guess, and also 0. Right, then Wi-Fi manager disconnect, we're not gonna do it, and we don't use request in progress anymore here, essentially. Okay, yeah, request in progress is not needed, because that is now just a method that takes callback and calls the callback when it's ready. There is one thing missing here, which is synchronizing with the time. So for that, ideally, I am going to, let's just move to it before I compile and deploy. So So we're gonna look at the set clock and think about how to make it non-blocking. But first of all, I'm going to remove it from here because as you've probably noticed in APIGatewayTemperatureClient, I've just removed Wi-Fi disconnect because I'm changing the behavior for the APIGatewayTemperatureClient for the entire program, essentially. Which is, we're not really gonna be connecting and disconnecting. We're just going to connect and stay connected. So we got that covered, and now the time, right? I'm going back to the set clock. Set clock is what we care about now. So setting the clock essentially is a responsibility at this moment of APIGatewayTemperatureClient. We only need to set a clock for verifying SSL certificate. So what I'm gonna do is to move entire function. I've already removed it from the listeners. Entire function is gonna be moved to, for now here, I'm actually even thinking about making this private. So setClock will be just a private function of APIGatewayTemperatureClient. This functionality, this responsibility is going to be extracted in 5 minutes or so, because there is another thing on my to-do list, which is extracting the pure logic for sending the request from APIGatewayTemperatureClient. The temperature client should be temperature specific, but not request specific, right? It may know about the endpoint and about what to extract from the endpoint, but not about the logic, not about the fact that it needs to synchronize with the clock, not about the fact that it needs to set the HTTP method or a certain header. Maybe header is fine, maybe even the method is fine, but it should be done in a way where you just say, yeah, this is the method, I pass it as an argument, but not that, it uses some HTTP client class like here and does all this stuff in there. But yeah, that's gonna be in a couple of minutes, because I need to deal with the set clock now, which is essentially at the moment is blocking, and I'm thinking about making it non-blocking, which I could do by introducing the callback function again that takes a void and returns a void, and we say on clock synchronized, or on clock set is gonna be easier because it's called set clock, right? So on clock set, we set the clock and the timeout. Let's use the timeout. So that's gonna be unsigned long timeout ms, and we can set the timeout for 10 seconds, I guess. That takes a while, right? You remember. Okay, config time stays as it is. And this part now, we have a really nice functionality in the timer to deal with this sort of situations. So what I'm gonna look at first is add the dependencies, the class dependencies. Actually I'm going to move the private section below, because I've realized this is a standard in C++. So that's gonna go below, and I'm going to replace event dispatcher with the timer, and that is gonna be what I require now, because the event dispatcher is not used anymore here in this class. So let's replace it with the timer, which we are going to use. So that's gonna be timer equals timer. And that timer is gonna be used in the way that, we essentially care about that to be run on the loop. That will be run on the loop until now is higher or equal this value, right? The opposite to this condition. So you can even keep waiting for NTP timesync and then just do this timer, set on loop until. We also want to use the timeout here. So that is going to be on timeout. So you may actually specify some sort of error in there. And the last one is going to be the timeout milliseconds. Okay. So yeah, essentially I could here we can return boolean, I guess. That is going to indicate whether it failed or succeeded. Okay, so set on loop until. What we're going to do, what we're going to need there, I think it is just on clock set is the only one. Because what's going to happen there is this one. And then the check. Right, there's gonna be the check. And that check essentially is if now is greater or equal to this value, that means the time is synchronized, right? It is already synchronized. That can only happen for the first time because, you know, later on, we don't really have an easy way to check if the clock has been synchronized. Yeah, probably there is one, but you know, there is nothing. I haven't really done the research on it, so yeah. I only know that the first time is easily to spot, which is like using this being run in the loop. So if that happens, this is the moment where we want to run on clock set and we want to say true. Right, this is the moment we want to say true, and we want to return true as well. So that is going to stop, right? The interval is cleared automatically for us. But if there is a timeout, we want to say on clock set false. Okay, and when it happens again, and by that, you know, next time the clock synchronizes, right? Because we don't really have a controller of a config time. When config time is called, I think, you know, it's just going to eventually synchronize when it can. So there might be the case the timeout happens, and second after the timeout happens, the clock is synchronized, right? But it still returned it as an error. But there is going to be another attempt, and then that code is going to be executed. And if now is going to be greater, then that means the clock has been synchronized and we can return a success. Okay, this bit not required anymore. This bit, I can put it, this is simply a println to tell us what the time is. It's fine by me. And obviously return false otherwise, because that callback needs to return boolean, so true or false. And on clock set is done. Cool. So there is no this used inside the callback, so I don't need to pass it there. Just on clock set. So that's how set clock works. It is potentially something to be extracted from it. I'm not sure if this is responsibility of that class, but small steps, right? Okay, and right here, the WiFiManager connect and on load. This is what we're going to call it. Yeah, on connect. We want to first of all run set clock, do we? And only when the set clock happens, we want to run all of this. And to avoid having, like, you know, two levels of going deeper, having a code inception, I'm going to clean this a little bit. So let's move the logic from the sending HTTP request to a separate private method, and let's maybe call it like get temperature. I guess get temperature is fine. Get temperature. It's gonna be refactored anyway, so the get temperature makes sense. Get temperature is gonna just run this, all of this. That is get temperature, and that can take on load, right? That can take on load. So that would be, I mean, that could really run, that could be called get temperature as well, but I think it was my idea to do that, to rename it. But this is, the factoring here is not over, so temporarily this is fine. So now we have load temperature, and actually load temperature, this is also going to be like that. So on load stays here, right? So we have connect, we want to pass on load, and then when it connects, so connect, does connect tell us anything about Wi-Fi status? I think yes. So we get status T, and that is status, right? Here I can check if the status is WL connected, and only if it's connected I want to do set clock, which it cannot really see right now for some reason. Like there was some issue here. No, doesn't seem. Oh, this is not passed here. So that's gonna be set clock. And now in set clock, we essentially need to pass the on load and this, and we're going to get something like success. And here, only if it's true, you know what, let me just reorganize this a little bit so we don't have too much nesting. So if status is not connected, we want to run on load with an error, could not connect to Wi-Fi. And the second argument is going to be just 0. Right, and then return. So that doesn't continue. And then we have set clock. And again, set clock if there was no success. We want to run unload with could not synchronize the time, but do I return could not synchronize the time, or that's something I need to tell myself? Oh yeah, I need to do something like this. So could not synchronize the time, return, right? And 0, that needs to be also returned. So that'll be for set clock. And otherwise, this is where I want to do this load temperature, right? You know, load temperature essentially doesn't really need to call the unload inside, because this is blocking operation, right? We can get the result from here, but because I've already refactored it in a way that the onload is called, I don't see anything against passing it like that. So that can be handled by the load temperature now. Okay. Yeah, hopefully with so much nesting and everything, this is still gonna work. Okay, before I try to deploy this, few things to fix now. So one is to load okay, so load the temperature needs to be implemented. Quick look at the dependencies. So now we have, instead of dispatcher, we have a timer here and WiFiManager. And right here we have we have load temperature now. A load temperature, because that is going to be run in the setup, is going to be run for the first time in the setup. I need to move it along with those functions here before the setup. Otherwise, the setup is not going to see those functions. Some compiler option to make possible calling the functions that are below, but it is not set here in this environment. Okay, and now in the load temperature, this is where I'm going to run the gateway stuff, right? So that is TemperatureClient dot load temperature, and here we expect to get a const error and float desired temperature. So that's our desired temperature now here, not required here, just there. So that's what we're gonna get. So load temperature, and what I want to check if there is any error. So if error is different than null pointer, I want to do serial printf and loading temperature failed due to, and let's do print s, and that is going to be error. Obviously I need to do the new line after that, and return. That's it. Oh, maybe actually not return. I will show you, I will tell you why in a second. Else what we want to do is this bits. So that is not required. So this bits, this is what we want to do now. In the loop is just timer tick, and we want to do this bits. So that happens now there. And this is the deepest callback, you see, the deepest callback, load temperature. This is the deepest callback. This is the deepest callback, regardless whether it failed or not. So this one or this one, I want to load the temperature again. Call this, call itself, set another timeout, and continue. Okay, so essentially that is it. That is it for loading the temperature. And what I'm gonna do now is to first of all compile to see if I haven't done any mistake, which I suspect I did. Did I? Oh no, that works right away. Okay. Nice surprise. And I'm going to deploy. Okay, it is deployed. Let me quickly restart it. Okay, nothing happens. Okay, I'm gonna quickly go through the code to check again if there is nothing that I missed. Oh yeah, there is something that I missed. I don't call load temperature here. The most important call, the entry point, and I didn't do that. Okay, deploying again. Okay. So we got a reset, which is an error right after NTP timesync. So NTP timesync caused an error. Okay, let me have a look at this and figure this out, because essentially there is something I probably have done incorrectly. Okay, that took me some time, but I've done investigation, and I've got two issues here. One issue, that's simple, that should be get temperature, right? But it's not the cause of the problem. The cause of the problem is the fact that we call this callback first, and then we dispatch on the dispatcher. And to be honest, I have no idea why this is working like that, but it doesn't work like that. I have no idea, because there's nothing unusual happening in unconnected. Unconnected and dispatcher, they have nothing. They have nothing to do with each other, right? They completely separate, because unconnected gets, passed as a parameter to the connect on WiFiManager. And there is nothing listening on Wi-Fi connected event, related to APIGatewayTemperatureClient itself. So for some reason, calling this first, it changes this pointer to this. I don't know what exactly happens with that, but essentially if you try to access dispatcher on this after this call, it doesn't work. Let me just show you how this should work. So I'm gonna deploy now. And after I've got in my mind another experiment. It might be due to the fact that the dispatcher is private, but I don't see a reason why that would, make a problem here. Yeah, anyway, let's give it a few seconds to deploy. We see if it's working now, because clearly I did the investigation and that should make it working. So let me just restart and let's see. So it's connecting to Wi-Fi now. Now it's waiting for NTP time sync. It does it still waits for it. Oh yeah, now we have low temperature failed due to could not synchronize the time. Oh, there is something I need to fix as well. And let's see if it can do it the second time. Because yeah, that takes some time. Yeah, no, not again. I wonder how long this is gonna take. Anyway, just on set clock, this one needs to be print ln. I'm probably gonna have to speed. Okay, so now we got the time synchronized. You see, it just takes some time for the time synchronization, and it invalidates all the callbacks. So now we're getting the temperature. Now we're getting it nice, right? So 22.5. Even though another thing I realized, we still disconnect at the beginning, right? This is still following the previous approach. I mean, as I said, it doesn't matter. We can keep this approach if we want to. What we could do is once we load the temperature, we can essentially disconnect if you want to. Here. If you like to disconnect Wi-Fi, it should be fine, because it won't let the request to happen or time to synchronize if the Wi-Fi is not connected on that safety check. Is it this one? It's this one, right? Okay, that is working. And one simple experiment that I really have to do, because there is something I don't see a logic in it, but it's not because there is no logic in it. This is because I'm clearly missing something. So if this is here, I don't know, it doesn't work. So what I could do, I guess that doesn't make sense, but let's give it a try. So even dispatcher, get dispatcher, just a getter. So this dispatcher, And now here, I'm just gonna do exactly that. Get dispatcher and dispatch. But it doesn't make sense. It doesn't make sense. Well, let's see. Okay. No, that is obviously it is still failing. So it stops on the waiting for NTP timesync. But I investigated that, and essentially it is that line of code. There's nothing else. It's this line of code. This dispatcher dispatch after on connected. For whatever reason, I have no idea why that is the case. What if I do auto dispatcher equals this dispatcher, and I pass this dispatcher as a right, and then I do this. What happens then? That's gonna be my last try. If this doesn't work, and someone knows why it doesn't work, I would really appreciate if you told me that. I'm really keen to learn about this aspect of C++ with working with lambda functions. Okay. Okay. Come on. So now that's all right. Now that's all right. So apparently if you copy the pointer to another variable and you pass it as a variable, then it's all okay. It doesn't make sense. Really, it doesn't make sense. To me, no way. So what the unconnected does, the pointer disappears. Okay. I really need to check that now. So dispatcher, that's fine. Okay, I pass the dispatcher like that. Can I pass this by a reference? No, clearly I cannot. And that is also not possible, I'm pretty sure. No, and that is also not possible. If I do this dispatcher, no. Okay, but yeah, essentially I can, if I do dispatcher equals this dispatcher, and then I just use dispatcher like that. I think this is how this should be done. No, that's not. Oh, essentially this is because then this Wi-Fi run and this connected is not working. Okay. So that would still need this. Okay. But this Wi-Fi multi is also a pointer, and this connected is just a boolean. Okay, last try, and that's it. And that's it for the WiFiManager and dealing with the lambda functions in C++. Okay, while this is deploying, let's start thinking about making the APIGatewayTemperatureClient. I mean, extracting the logic for making HTTP requests from out of HTTP APIGatewayTemperatureClient. That is something I would like to do, but let's have a look at the result now. No, that is failing again. So yeah, essentially the only way to make this working in that configuration is to have the dispatcher to make like a copy of the dispatcher here, of the dispatcher pointer, right? And then put the dispatcher like that, and that is going to work anyway. That can deploy in the meantime, so just to double check this is working. Okay, So API Gateway Temperature Client. Right. First of all, I don't want to be that specific that I have the URL hard-coded in the code. That is one thing. Another thing is, setting the clock. You know, getting the temperature has nothing to do with setting the clock. Sending the request, yes. Oh, okay, that is not working. Okay, I've done additional research, and it looks like what matters here in the capture section of the C++ Lambda is the order of parameters. I couldn't find why, but essentially if this is the second one, I mean it comes after onConnected, then we can for some reason use it after onConnected in here, and there is no error now. So let me just quickly deploy and show you this. Yeah, it doesn't make sense to me a bit, unless there's some hidden rule I don't know about. And if you know, let me know in the comments. I would really like to find out about this. About that rule, if it exists. Okay, so I'm going to connect to the serial monitor and restart. So let's see now. We should have no errors. Yeah, waiting for NTP timesync. Yeah, loading temperature failed. Again, that's gonna probably try a couple of times, but essentially we don't have any exceptions now. Right. Okay, yeah, this is just gonna continue until the time synchronizes. Okay, so now let's move to API Gateway Temperature Client, and that is going to be the last step in terms of refactoring today. After that, I'm going to create a library out of all of those classes that I have created today, the utility ones that can be useful with the future projects, right? But yeah, what I would like to achieve in the API Gateway Temperature Client is to extract the logic for making HTTP request. So instead of, having to do all of this that I have in the get temperature, which is, you see, like initializing bare SSL, certificate, setting the certificate, all of this HTTP begin and reading the payload. I would like this to be enclosed behind a nice interface that I can just, that can just work like one of those request libraries that can be found in a different programming languages, where you have one method or one function where you pass a path or URL, right? A method, headers, and so on, right? And as a result, you get back the response body. Yeah, the time synchronization takes a while. I mean, it's not that we care about this right now, because first of all, I would like to, maybe I just remove this from here. The serial monitor, I'm just gonna terminate. Right, okay. So what I'm gonna do for this client extraction, client logic extraction, is to implement a new class that I'm going to call SingleHostHTTPSClient. And that SingleHostHTTPSClient is going to take, in a constructor, is going to take, first of all, the PEM certificate. So we'll take const_char PEM set. And that's going to be actually the second parameter. And the first one is going to be the host, right? If it's single host, you want to have a single host pass to the constructor that is going to be to our API gateway, and the possibility to call different paths, right? The reason this is single host is simply the certificate right? The purpose of that class is going to be to have a HTTPS client for a single host, many endpoints on the hosts, but a single certificate, right? There's other way to actually to make the ESP working like a browser essentially. So having the possibility to call any HTTPS URL, but I mean any value with the valid certificate, obviously. But that's for another video. Okay, let me just create the class variables for host and PN set certificate, right? And we want to have yeah, that's what I have to do. And what we want to have is, because that one is a HTTPS client, so that would be the class responsible for the time synchronization. So I'm going to move a set clock in there. Entire set clock is going there in the private, as a private method, right? So set clock is now here. What about the Wi-Fi? Do we need a Wi-Fi as well? I would say so, right? I would like the single host HTTPS client to be self-contained. So essentially, I would like it to do all the work for me. And as a client, as a consumer of this class, you know, the only thing I would have to do is to pass the appropriate dependencies to the constructor, and then I can just start using it. I don't need to think, I don't need to remember about any implementation details that are required for the class to run. So what I'm gonna do is to make the WiFiManager. I'm going to make the WiFiManager a dependency. So that is going here as a dependency. Not like this. Yeah, so WiFiManager is gonna be the dependency. And yeah, that needs to be taken in the constructor as well. That needs to be taken in the constructor as well. So we have WiFiManager. Right, I think the timer is also required, because along with WiFiManager, I'm gonna have to move this WiFiManager connect method that uses the set clock as well, because you know that's for the clock. Ideally, clock would be a separate class again, and then a dependency on the single host HTTPS client. But because I do small steps, I'm just gonna move everything in there first. So that is going to here, right? That is going to here. Hang on, that is low temperature. So what we will have is possibly something like, for now, let's make it void, and that will be send request method, and that this is where I would put this code, right? So that is going to be WiFiManager, but yeah, on load, instead of on load, we want something like on response. And some sort of response, which I don't have yet. But you know, I can define it essentially. So that will be on response, and I need to define that as a struct. So struct response, for now this struct is going to be empty, right? So that resolves, that calls the callback, the past callback, when there is a response, right? Because setting the clock is asynchronous operation. We need to wait for this to happen. And that's why that also needs to be callback based. So we've got that covered. Obviously that I need to remain on load now. And that on load is going to take, that's going to be a bit different on here. So commenting this out, and that is going to be different here. I haven't defined the error handling yet. So for now, I'm just going to comment this stuff out. So yeah, so now we only left with this bit on the get temperature. Yeah, this bit is not required here anymore. So we don't want that. We don't really want that. That should be, the API gateway temperature client should be just temperature specific. So the only logic we need here is making the actual request. So for now, what I'm gonna do is to create an instance of this class, sticking to small steps, right? So there's gonna be instance of this class, and that class requires, in the constructor, it requires host, PEM certificate, and WiFiManager. So yeah, that also makes the WiFiManager dependency on the temperature client. And basically that could be, they could be shorted to making the dependency on the HTTPS client itself in here, in the API Gateway Temperature Client, but that comes next. So for now, as we have WiFiManager already here, right, and we have the host here, which I can essentially copy and paste as a host, but a host would be without HTTPS part because that's protocol. So that is host, then PEM certificate. We have it as a set, right? And we have WiFiManager, which is simply already here, right? So now I'm going to put it like that, and then on client, we're going to make the send request, and then pass the actual response should be public. So now we get there is set temperature. This is not needed, right? So send request, and then when the request is done, we want to get the response. Right, that callback is going to be called. And inside the response, there's going to be the payload. So let me define the payload on the response itself. I'm gonna call it body, because this is how it's usually called on the response. So we have const char body, and that const char body now is going to be the thing that we're going to read. And we're going to simply do that, right? So this bit is what we are interested in, and then on load is going to be what we passed in here, right? So I will have access to response, so I can read that response body, okay, and read the temperature from the response body, and then just simply call on load with the temperature that I've read from body. Some error handling though, but that comes later. There's going to be error handling here as well. But yeah, essentially this is how the API gateway client should look like. And this part on getting the temperature, that is all gonna go to the send request. To the send request probably, or to actually maybe I will just move it to the sender request. But for this to work, we need to think about error handling now. So the simplest way for now that I see is to define a const char error. So we can send it as an error. If it's null pointer, there is no error. If there is a string behind the error, then that means there was an error, and there is no point in reading the body, because body is going to be null pointer then. So yeah, remember, we don't have exceptions on this environment. They switched off. So there is not really any way other than just sending this as a value, the error as a value. So what I have to do, so for the Wi-Fi, obviously that also could be configurable. I mean, we could strip the dependency to the WiFiManager and have some ifs statement for the WiFiManager for the clock synchronization to like check like if they not set right on this class, then this class is not going to even care about that. But for now, as I said, I would like this to be self-contained for the client of the class, so it is going to deal with WiFiManager and with the clock. So that uses WiFiManager to connect. We have on response, and if the status is not WL connected, then we're going to simply run on response, and the response that we're going to send here is simply going to be for the body, that's going to be null pointer, and for the error, could not connect to Wi-Fi. That should do, right? It's just a string error. I may think about more sophisticated error handling later on, and that returns, right? And because this is callback based, we don't have to worry about the response going out of scope. I think so. I'm not sure. I will see that running. I will check if this is the case when it's running, but I think that should be the case, that the response is just gonna be passed to on a response, and then all of this goes out of scope. So after return, so that should be fine. For on clock, simply on a response, and we're sending the response again with the null pointer, and I can simply copy this message. So that's the response now. And this bit, so that is for setting the clock, and this bit is simply going to be doing all this stuff that is required to make the request, right? So I can either have a method on this class, or I can copy the entire block of code from getTemperature, which I'm going to do first. And I think how to organize this code later on. So that is not needed here anymore. Makes this class very small, but also makes this class way more generic, so that can be reused. Okay, so set clock, that happens, and only if there was an issue we send that, and otherwise we create all of this stuff required for making the request. Okay, few adjustments here. So when we begin, we use the hard-coded URL. That should not be the case. We need to define the URL with the length of, that's essentially gonna be some mathematic operation too, because I'm using C strings. I need to calculate how big the C string should be. So that is going to be that's going to be the length of host plus the len of when I send the request, I would like to get the path. Okay, so the response is good to get the response in the callback, but I need to have the way to specify what sort of parameters I would like to pass. And that would be something like method, for example, or something like headers. So I need something like a request, right? And for that, I'm going to define a new struct request. And that request is going to have, definitely, it's gonna need a path. Because that's what I essentially need right now. So response, I can make it sorry, that's gonna be request. Request, it could be a pointer for now, request. So that would be request, and what we need here is the request and path. Oh, this is not picked up yet, but yeah, essentially that's what we need. So it's path, and we also need a length of the HTTPS like that, and then +1. Okay, so that is going to be the length of URL. That is going to be passed here, but I need to do some copy operation on the URL itself. That is going to be host. Sorry, that actually is not going to be host. That's going to be HTTPS. That's how it starts. And then concatenate it with the host itself, and then add the path. So that's gonna be request path. Okay, and now the URL should start as this one. So you know what I could do? That could be printf, and we could have a nice comment in here, a nice printout here with the URL itself. So we'll see what was the URL. And with method I'm gonna deal later. Okay, so that would be for the begin and for URL. And now the payload itself, right? So this is not going to be the part of the base HTTPS client anymore. And here, this is gonna be the place where I would like to essentially call the onResponse. So that will be onResponse, and response is going to basically to return the body and null pointer for the error, or it's all the way around. Hang on, can't remember now. Yeah, the body is the first one, so yeah, and error is the second one, right? So the error is now null pointer. Okay, so that is gonna be for the response, and naturally here, that is also going to be onResponse. onResponse, and this is gonna be a null pointer, and that is going to be the error that I want to put on the response, and that finishes HTTP request. If it cannot connect, I need to also return a response, but this time with null pointer on the body, but this time I need to essentially set the error myself. So that's just gonna be unable to connect. Unable to connect. Okay, so these are three places, three possible scenarios, right? So one scenario is when we end up with response in here. That is only when the HTTP code is okay though. So that still needs to be addressed somehow. And that is going to be addressed somehow, because HTTP code is essentially something that we would like to have on the response struct, and I'm going to add it there. So, you know, maybe the error is going to be the first one, the body the second one, and then we can have the rest of the maybe even the status code as a second one. So the status code is actually going to be int status code. So the error is always first, and that is gonna make it a little bit easier, but at the same time I have to change the order now. So here the null pointer is the second one, and we also need the, you know what we need? We need the status code. Yeah, so we need the status code that has to be something. So I'm gonna put -1 if it's unrelated to the request itself. So here is also gonna be -1 and null pointer as a body. And now that's gonna be easier to handle it here. Because what I essentially could do, yeah, so HTTP code now is going to be simply put as HTTP code. You know, this is actually not an int, is it? No, hang on. That if is not needed. And hang on, if I go to HTTP code, accepted, for example, I'm pretty sure this is enum, THTTP codes. THTTP codes, so I could even make that, unless this is THTTP codes, but the -1 is not included in there. So yeah, so let's just keep it an int. Okay, so we got response handled in here with the payload. Here, obviously, again, that needs to return some HTTP code, which is probably gonna be -1 or 0, but let's just put the one that we get from HTTP code, and that is null pointer. And then -1 for here, right? Because this one, this scenario, it couldn't even connect. Okay, right. So now we have this scenario handled with in an asynchronous way with the callback, and WiFiManager is here as well. Okay. And for the set clock, let me just quickly confirm if this is all right. So set clock is fine. Yeah, all of this print ln, they will be removed. Actually not removed, but replaced with a special macro. But I'm gonna explain it the other day. So for now, let's keep them as a debug information. But in the future, there will be just a macro. So we won't see those messages, for example, in the production mode, or if we set the logging for the certain level. But for now, let's just stay with what we have. Okay, so setting the clock it seems to be fine, and here we just have a simple logic. However, yeah, let's handle the error now. So temperature is only read if the response error is different than null pointer, right? So maybe other way around again. So if it's not the null pointer, so it was actually right. If it's not the null pointer, we want to run unload with the error, right? So that would be response.error. You know what? I could actually call this with the response itself, but yeah, let's just stick to what we have for now. So response error, and the float, essentially that value, the temperature, is going to be 0, and that's it. That ends here. Otherwise, if there is no error, we just read the temperature and from the body, right? And we just call onload with the temperature here, right? So essentially what we have here is 2 layers of abstraction. The first layer of abstraction is to load the temperature. That can be called get temperature now, because essentially it's not like it does something in the background. it gets at as temperature and notifies us, calling the onload callback when the temperature is ready, right? Yeah. And what it does, it creates a single host HTTP client with the certificate and everything, send the request, and then sets another callback to wait for the actual response and handle this response, right? And depending on the response, we call unload with an error or with the temperature. So that is it. Not everything though, because that only handles get method, right? We would like to have more methods essentially. And the path. I forgot about the path. So this is the request part that is also required here. And you know what? To make the code, sorry, this is not here. It should be here, right? So to make the code a little bit more verbose, I'm going to do something like that. So that would be request, and I'm just going to set anything that is required for the request. So path, and path in our case is, I think it doesn't exist here anymore, but that essentially is depth temperature, as far as I know. Yeah, we will find out when I run the code. So request is this, and then this is important because request needs to be passed as a pointer actually here, right? So that's passed as a pointer. You know, the response could be returned as pointer as well. I'm just thinking. So why not do that? So it doesn't have to move, right? It doesn't go out of scope. Oh yeah, that's gonna be a little bit tricky. Okay, maybe that's gonna be the next step. For now, let's just run this code. So now I'm gonna compile, see if the code is correct, which is not, unfortunately. The reason it is not is simply because the onload has not been captured. So now onload is captured here. Let's see what else. Something in the main CPP. Oh yeah, that it is main CPP as well. Some other issues here. So timer is required. We don't have a timer on the single host HTTP client. And on response is also not captured here because we have onload. So that's something to change. Then the timer is going to be another dependency. And is there anything else on response? On response, request path, there is something about the request itself. Oh, because the request is not captured either. So we need to capture the request as well in order for the request to work, and that request needs to be captured in here as well. So to be honest, I think there's everything that's coming from here is being captured. So in that case, I'm just gonna, use the equal sign to capture everything. And the same thing applies here. Oh, this is actually not the case. This is not the case because we don't need status. Okay, let's see now if I've got rid of all the errors or not. Probably main CPP is going to be the last one left. No. The WiFiManager here, no magic function to call. Oh yeah, that is correct. We need to pass the timer. And what's left here is it doesn't like the null pointer in the response for some reason. And it doesn't like it just here. Convert, okay, yeah, that makes sense. That should be C string. So now we're left with main.cpp. And main.cpp basically needs, yeah, it's just on the temperature. So that should be get temperature right now because I renamed the name of the method. Okay, warning. And that warning is there. What's wrong with the warning? In lambda function, HTTP client begin URL begin string is deprecated. So what I've done wrong is this is not a string. URL is char. So what is wrong in here? Oh, that needs client as well. This is how it's been before. Yes, okay. Okay, so let me deploy this code. And we see if this is working as it's supposed to work, or we get another exception. Because of some weird capturing rules, right? Okay, restarting. Okay, yes, there is an exception here. And that exception is about, oh, we don't even know about what this exception is. Right, okay, let me have a look. Maybe I should have done smaller steps. So yeah, we have an exception, and I've already debugged that exception. And apparently the issue is with, let me just show you, with having too much on stack, which is caused by creating an instance of the client here. So I need to do it before the code actually. So yeah, I should have done the full refactoring before deploying the code, because now we're getting this. So what I'm gonna do is to quickly just, yeah, we don't need an event anymore. I haven't noticed it before. And then WiFiManager and timer, they're not required here, but instead we're going to need a pointer to a SingleHostHTTPSClient. So now that is going to be the only dependency on the APIGatewayTemperatureClient, which technically I could even turn into a single function, right? Yeah, at the moment I could even turn it into a single function. So maybe I just do it straight away. So that would be get temperature, right? Yeah. So what we're gonna do is to take the pointer let's just simplify it. So take the pointer here, right? And the callback. And then we don't need all this stuff. That is essentially gonna go to the main.cpp file somewhere here instead of this one. This one is not required either. So that's gonna go here. And what I need also to move is the certificate, because certificate now on is added. That needs to be initiated here, right? So we need to pass it here essentially. So the WiFiManager, that's gonna take address to WiFiManager, and that's gonna take an address to timer. Okay, And the temperature client, yeah, essentially this one I'm gonna have to extract, but that's gonna be in a second. So get temperature now is just a function, and that client, because it's a pointer now, I need to change the operator, this to dot. Okay, so that should do, I think so. Let me just see if it compiles. Something missing. And that missing thing, okay, so that's not cert anymore. This is something I have missed, which is a PEM certificate. And obviously in the main.cpp file, I have to change the place where we call the get temperature, because now this is just gonna be get temperature. And apart from the callback, I need to pass the client, right? Maybe I call it HTTPSClient. HTTPSClient. So we have better naming here. And address to HTTPSClient, right? So now, if I do that, yeah, that compiles. Cool, and let's see if it works. So yeah, there is no exception. Now we're waiting for NTP timesync, which failed, but let's give it few seconds or few minutes. Okay, another exception that we got, which is happening right after HTTP begin. Okay. Yeah, and that problem is simply my fault, because I haven't noticed that this struct goes out of scope before anything on those callbacks is being called. So it tries to do it on something that doesn't exist, and that's why we're getting exception. So there are two solutions. If I want to keep the pointer, I would have to change it to the smart pointer. So I could do unique pointer, for example. Or, which I think that is the solution I'm gonna go for, is to take take the request instead, not the request pointer. That changes that code. So that's gonna be now request.path and request.path in here. And now it's going to just, copy it, right? It's just going to copy it. And here, instead of passing it like that, I could actually even do, or maybe I could actually do, yeah, let's see. That's probably gonna pass the copy, right? So even if this goes out of scope, we should still see the values there, right? Essentially, when the callback is executed, because that's gonna be all copied. Okay, let's see. Okay, I'm connecting to the serial monitor. Quick restart. And yeah, we have waiting for NTP timesync. And let's give it a few seconds. Okay. So you see, that almost worked. Loading temperature failed due to 22.5. It treats the temperature as an error. And the reason is, again, that should be null pointer. Yeah, it seems like, longer the video, more mistakes I'm doing. So that is it tells me that I should finish it soon, which I'm going to do, because essentially what is left on this subject is going to be extracting all of these useful classes and making a library out of them. There is also the method option, but I'm not gonna do it now. We're gonna do the method along with, I guess I'm gonna do it along with the certificate store. So there's gonna be another type of HTTPS client with the certificate store, a separate video, probably day after tomorrow or day after that day. And then I'm going to add the method support here because there is some additional work and I don't want this video to be any longer than it is actually. It's I think it's 3 hours now. So I need to focus on finishing it. Okay, so you see, now this is all working, right? We get the temperature, 22.5. 22.5. So yeah, finally success after all this, after, all this struggle that I had with that. We're finally getting temperature. The code is a little bit better organized. This is still not ideal, but, again, I managed to prove that it is possible to make the code asynchronous, callback based, but still, keeping the events. And I have this set of classes here, like timer, like even dispatcher, which is not complete, yet either, because again, like you remember, like on timer, we can clear the timeouts and intervals. On even dispatcher, it is not possible at the moment, so there is small improvement that needs to be done. But essentially, yeah, that is going to be done. I guess I should have a chance if with the different project, right? I will have a chance to improve them. For now, this is enough. And what I'm going to do for this bit, for the SingleHostHTTPSClient, is to put it into a separate file. So let's call it SingleHostHTTPSClient. And that SingleHostHTTPSClient is going to get copied. The whole thing is gonna go there. Along with the includes required for that, which is going to be all of this. And now the APIGatewayTemperatureClient can simply become getTemperature. And that getTemperature needs to be included here. And also the HTTPS client, SingleHost HTTPS client, right? So this is included now. Let me see if it compiles or if there is anything missing. There might be something missing because on getTemperature there is a SingleHost HTTPS client that is also required. Maybe it actually, yeah, that works, but I would still like to make it add the include in here. Okay, and to not have to copy everything over to the next project, I'm going to extract those utility classes to a library. So adding something as a library, that just requires me to create a folder in this folder, in the lib folder. I'm going to call it core for my core classes, And then the structure is as follows. We have docs, examples, src, and probably test as well we could do. And optional JSON, which we don't need. So the only thing I need here is the src. There is going to be another folder, src, right? And then in the src, which actually is not that important. It doesn't even have to be src if I don't want to. I guess that depends on the design. So maybe actually I get rid of src. And let's just copy let's copy event dispatcher, SingleHostHTTPSClient, WiFiManager, and timer. Actually not copy, let's move it there. Okay, so move to the core. And now let me try to compile, because if it doesn't compile, that means there is something wrong with the... Oh, okay, that compiles. Okay, that compiles. So we can just have a core folder here as a library, and that library can be basically included like anywhere, right? We will just have access to these folders. Maybe what I could do though, I'm just thinking, if I specify, let me just quickly check. If I specify folder src, and let's move one thing in there, maybe even dispatcher. Can I still have access to event dispatcher? Include event dispatcher. Yeah, that seems like it is possible. So if I do that, let me check if anything happens. No. SingleHostHTTPSClient. No such file or directory. So that seems like, yeah, it's this way or the other way. If I move all of them now to this src, because I think this is actually a better structure, because if I want to add the tests later on, I would like to have them separated. Yeah, that works. That works, and even better if I want to, I'm pretty sure if I want to require developer to use something like, you know, an event dispatcher, for example, something like this, I could essentially make the developer do that. But I think what I could make use of is a namespaces if I really want to, you know, sort of separate my code from any other libraries to not have any conflicts. But for now, I can live with that, because, you know, that what I need is just a set of small classes to handle the basic functionalities. Great. And even better, for the get temperature, only the SingleHostHTTPSClient is required. And in the main.cpp, I think this is actually where we need everything, don't we? Yeah, WiFiManager, SingleHostHTTPSClient is also required here, and timer. I don't know why I still have a ticker. I remember removing it. I don't know why it's still there. Okay, so now this is clean. Okay, one last test to make sure the library works, which I'm pretty sure it does. And this is gonna be it for today. So let me just quickly do the last test then. Okay, as you can see, this is working fine. Everything's great. So yeah, if I wanted to save energy, for example, now, so go back to disconnecting and connecting to Wi-Fi, I could simply do that by just going to, so yeah, first of all, I would change this to 30 seconds. That is actually gonna be the code you will see on GitHub. So that will be 30 seconds. That is going to ensure connection to Wi-Fi. But before I load the temperature, again, I'm just going to run WiFiManager disconnect. So that should disconnect it. And because of that, we will save some energy because, like, you know, it's gonna wait 30 seconds until it tries again. And then it's going to do everything, you know, connect and then disconnect again, and so on and so on. Cool, nice. Yeah, and I'm going to deploy and quickly summarize. So yeah, that was a super long session, super long refactoring session. Please let me know in the comments if you liked it. If it was boring, also let me know, because then I would try to make it more entertaining, right? Not just, you know, me coding and commenting. Maybe I you know, I add some fireworks, I don't know, figure something out. And yeah, this is it for that project, for that particular project. Doesn't mean I'm not going to work with the temperature sensor anymore. I will still gonna work with temperature sensor. And yeah, let me just quickly connect back here. Yeah, that's gonna take 30 seconds anyway. So yeah, as I said, I'm still gonna be working with temperature sensor, but this project is over. And for all the next projects, I always gonna start from scratch unless we have a, you know, a bigger project like this one. But I try to, like, from now on start from scratch for every single project. So there's not going to be one project based on another project. Okay, loading the temperature fade due to the could not synchronize the time. Yeah. So, oh yeah, there we go. So that works, right? It switched on the relay, and now we should have a 30 seconds gap until it happens again. Okay, and this is it for today. Thank you for watching. If you managed to watch entire video, I really appreciate that. And yeah, any question you ask me, I will try to answer. So yeah, don't hesitate to do that. If you have, or if you spotted any code bug, any mistake, if you watch entire thing and I've done any mistake there that may actually, you know, happen in the future, something that I missed, let me know. I would be really happy to know about that, and I would really appreciate that. And yeah, if you like my content, and you don't want to miss tomorrow's video, subscribe to my channel. Okay, that's it. Cheers, bye.